Okay, before we begin, I'd just like to confirm, can you guys hear me and see my screen clearly? Please let me know. Okay, perfect. Okay, Assalamu alaikum and good morning to everyone. Welcome back to grade 9 maths by Spine Teens. Yeah, myself. Cool. So in today's lesson, we're going to be finishing up the finance section where we're going to be doing exchange rates. Yeah, the last time we discussed, which is last week, we discussed compound interest. Before that, simple interest. Then we revised percentages and all of that. And now we are at exchange rates. We'll move on to integers, and let's hope we can finish all of that. Okay. So just some things to note, please. Again, just a reminder: if you guys have any questions, please feel free to leave them in the chat in the Q&A section. Or in the YouTube chat if you are on YouTube. That's number one. Number two is that the document will be uploaded to the drive, and the drive will be found in the group description. Okay, so you can utilize that. And another thing is on the drive, you guys will find the list of the topics that we're going to cover. Okay, in term 1, 2, 3, and 4 in order. Okay, so please go have a look at that so you guys are aware. Negative exponents plus. Okay, we'll get there. Okay, so let's go through exchange rates, right? So exchange rates, there are different money systems in different countries. Currency is the term used to describe the particular money system of a country. Here are the currencies of a few countries. So we have South Africa, Rand, United States of America, US dollar, United Kingdom, British pound. Several European countries use the euro. Okay, so we all know what different currency is. Okay, when you're traveling overseas, or if you're purchasing something from overseas, you have to convert to their currency in order to purchase something, and the currencies are not all a 1-to-1 ratio. Some currencies are stronger than others. Okay, so for example, 1 rand will not give you a whole dollar. Okay, in fact, 1 rand will give you an extremely small amount of dollars, meaning our rand is small. However, $1 will give you 17.40 rand. So that's obviously, that indicates that the dollar is a lot stronger than the rand. Okay, so this is really important, that the dollar can be written as a ratio. Okay, or the relationship between the rand and the dollar can be written as a ratio where $1 gives us 17.40 rand. So that's the ratio that it creates. Okay, so let us look at the first example. Let us learn how best to convert currencies and exchange rates. Sorry, just give me 1 second. Okay, cool. We may continue. Okay, so Nzako is traveling to Dubai and converts 10,000 rands, okay, into Emirati dirhams. How many dirhams does he receive if 1 Emirati is 4 rand 89? So for 1 Emirati dirham, okay, you're getting 4 rand 89. So what you need to do is you need to create a ratio. I'm going to call it the dirham to the rand is a 1 to 4.89 ratio. Okay, that's what you should always do. When you want to do calculations, what you need to do is, I'm not sure if we've done it, but when we did like ratio and rate, we learned that ratios can be expressed as fractions. So that's exactly what you want to do. You want to say the rand, okay, it doesn't really matter. Let's say dirham over the rand amount. Okay, and we've created this ratio in terms of a fraction. So we know that 1 dirham, okay, represents 4.89 rands. Okay, if we want to find out, so what you need to remember is this rate, okay, or ratio remains constant. Okay, it doesn't change. So for example, if you want to know what 2 dirhams would get you. You just have to multiply this guy by 2. So it'll be 89,78 or something like that. Okay, so the ratio is constant, right? So for every 1 rand, you are getting 4 rand 80. For every 1 dirham, sorry, you are getting 4 rand 89 cents. Since the ratio is constant, what you can then do is equate it to whatever you want to convert it to. So for example, it says Ntako is traveling to Dubai and converts 10,000 rand to Emirati dirhams. How many dirhams does he receive? If 1 Emirati dirham is 4.8. So on top is where I put the dirhams. So in this case, my unknown is the Emirati dirham. And at the bottom is my rand, which is known, 10,000. And this is how we do it. We create this equation using fractions. Okay, because the ratio is remaining constant. Because the ratio is remaining constant, we can create this fraction and equate it to one another. They are equal to one another. So when we have something like this, we can then cross multiply. So we get E times D times 1, basically. Or let's just, I don't know, what's the dinar symbol? Let's call it X, I guess. 1x is equal to 10,000, okay, times 4.89. Let's do this calculation, but it should be x is equal to 48900. Okay, so it's 48,900 dirhams. And basically, that's what we always want to do. We always want to create this ratio. So let's look at another example, right? 4 people travel to London and have supper at a restaurant. Okay, the total cost of the meal per person is $32. Okay, calculate the total cost of the meal in South African rand. If 1 pound, that's pound, is equal to 20.12 rand. Okay, so firstly, each person costs 32 pounds. So there were 4 people in total. So the total cost of supper in pounds was 4 times 32. This is the total cost of the supper in pounds. Okay, so now since we have the total cost in pounds, we can just create our rand to pound ratio or pound to rand ratio. So remember, we are doing pounds over rands. Doesn't really matter as long as you keep it constant. This is equal to 1 over 20.12. And then I want to keep it constant. So when I create my equation, on top, I want to put the rands. Do I have the rand amount? Sorry, I want to put the pounds on top and the rands at the bottom. Do I have the pound amount? Yes, I do. It's 128. Do I have the rand amount? No, I don't. I'm going to call that X. So in that case, it's going to become, I'm going to cross multiply, meaning I multiply X by 1, 20 by that. And I'm going to get 1x is equal to 128 times 20.12. And this is giving me the rand amount in for the cost of the meal, 2,575 rand 36. It's an expensive meal. Okay, so 4 people travel across London to have supper at a restaurant. The cost per meal is 32 pounds. Calculate the total cost of the meal in South African rand. We multiplied 32 by 4 and then converted it to rands. Okay, here's some more examples. Let's see which one can we look at. Let's look at the first one. Gold is selling at $423.50 per fine ounce. The exchange rate is 16 rand 35.12 per dollar. Calculate how much 2,500 fine ounces of gold. No, that's the same thing as we've been doing. Okay, let's look at the second one. Kim is going on holiday to New Zealand and has 22,000 Rand spending money. Okay, if the exchange rate is 0.09 New Zealand dollars to the South African Rand, how many dollars will she have as spending money? So again, this is simple, right? So we're going to say the New Zealand dollar over Rand is equal to the New Zealand dollar per Rand is 0.091. So I'm going to say 0.091. And how many Rands does that give us? That gives us 1 Rand. Or 1 Rand gives us that many New Zealand dollars rather. And this is equal to the dollar price, which is what I want to know. They want to know how many dollars is she going to have. So I'm keeping this constant, right? All of these are dollars. All of these at the bottom are going to be Rands. So the Rand amount is 22,000. Okay. So again, what do? I cross multiply. When I cross multiply on this side, I get X. On this side, I get 22,000 Rand times 0.091. And I get X as $2,002. Okay, so I hope it's making sense. Just we need to cross multiply. Let's look at this commission example. A commission is an amount a salesperson will earn on a sale of goods. It is usually given as a percentage of the sale, and this percentage can be increased if their sales increase. A property is sold for 580,000. 4.5% commission is asked on the first 300,000 and then 5.5 on the balance of the retail price. Calculate the commission paid when the property is sold. Okay, so basically, firstly, you need to note the commission is 4.5%. Okay, for the first property sold. For the first 300,000, 4.5% is earned on the first 300,000. Now, secondly, 5.5 is earned on the balance. So 5.5% is earned on the balance. So 580,000 minus 300,000 would be the balance. Going to give us 280,000. Now remember, we just do percentage calculations. In this case, it's going to be like 4 over 100, or you can just put the percentage sign in your calculator, times 300,000 over 1. Same with here. 5.5 over 100 times of means times 280,000 over 1. And you do these calculations. So 4.5% times 300,000. This is 13,500. And then 5.5% of 280,000. This is 15,400. I add the two together. And I get an amount of 28,900 earned as commission on the sale of a 580,000 Rand house. Okay, cool. So that's it, right? That's finance done. Please do complete the rest of the examples. They're not too difficult, right? Let's have a look at integers. Okay, so integers is going to be more of a revision. Give me 1 second. Okay, so we went through the definition, I'm pretty sure, of integers, right? In our first lesson when we did whole numbers. But nevertheless, let's go through it again, right? So integers, which is represented by the symbol Z, include whole numbers, which are both positive or negative or 0. So basically, the integers are your whole numbers, however, with negative numbers. Okay, of course, they include 0 as well, and they include negative numbers. Okay, so that's the important thing to know about integers, positive and negative whole numbers. On a number line, integers look like that. Okay, so this is important also to visualize, because when you're actually increasing integers, you are moving to the right. When you're adding, you're moving to the right. Okay. When you are subtracting, you're moving to the left. So that's important to note on this integer number line. When you're moving to the right, it's like you're adding. When you're moving to the left, you are subtracting. We're going to literally revise the extreme basics of integers. So when you add a positive integer, you move to the right on the number line. When you add a negative integer, you move to the left on the number line. Okay, so for example, we have -3 plus 7. Okay, so if we have to work on our number line, -3 is here. Okay, if you want to add 7, we'll just have to move to the right. 1, 2, 3, 4, 5, 6, 7. 7 times. Okay, and we'll get 4. Okay, alternatively, okay, if you're doing it in your head, right, how you could look at it is you can say from -3 to 0, okay, is +3. Then from 0 to 7, sorry. So from -3 to 0 is +3. So out of the 7, we've already added 3. Okay, so the way you can look at it is like you're saying -3 plus 3 plus 4. So when you add the 4, you get +4 as your final answer. Okay, so yes, that's how you can look at it, right? So like when you add 7 to -3, firstly you want to add 3 to get to 0, and then how many more numbers are left? 4 numbers, so you add 4 to 0 and you get 4. Let's look at this, right? -1 plus -5. So before we continue, we're not going to talk about multiplying, but we can talk about adding and subtracting, right? When we have two positives, so like plus, this results in a positive. Also, when we have two negatives, this also results in a positive because the negative and the negative cancel each other out. It also results in a positive. Okay. When we have a positive or a negative, so you're adding a negative number, it's basically overall negative. When you have negative positive, same thing as the one just above it, it's also just a negative. So these are the important things for us to remember. Positive and positive make a positive, negative and negative make a positive, but negative and positive make a negative. So in this case, I can simplify this to -1 minus 5 technically. Okay, because a plus and a minus. So now, minus is moving left on the number line. So if I had to look at my number line here, I'd move 1, 2, 3, 4, 5. Okay, in this case, -1 minus 5, you're moving left on the number line. That's going to give us -6. Let's talk about subtracting. When you subtract a positive integer, you move to the left. When you subtract a negative integer, you move to the right. So basically, when you subtract a negative, the overall is positive. That's why you move to the right. When you subtract a positive, the overall is positive. Sorry, the overall here is negative. That's why you move to the left. When you subtract a positive, then you move left. What am I doing? I'm mixing them up. Let's read them again. When you subtract a positive, okay, the overall is going to be negative. It's plus minus. However, when you subtract a negative integer, that's minus minus, which gives us an overall positive. So yes, this one is right on the number line and it's positive. Okay. Let's look at this. Note, subtracting a negative integer is the same as adding its additive inverse. The additive inverse of -5 is +5, and the additive inverse of -3 is +3. So it's basically the addition version of that particular number. So subtracting a negative is basically a positive. Okay, so what you want to do is, you don't have to buy out any of this, right? You just need to know that you need to know this thing here. Plus, plus, make a plus, minus, minus, make a plus. And when you mix them up, you get a negative. Okay, that's the main thing. And then you always want to simplify your question. Right, let's look at this. 3 minus 5. Okay, this one I can almost say like 3 minus 3 minus 2. So this gives us 0, and then I'm left with minus 2. Let's look at minus 1 minus minus 5. So remember, two negatives make a positive. So negative 1 plus 5 will also be seen as negative 1 plus 1 plus 4. This gives us 0, and I'm left with 4. Okay, I'm breaking down 5 into 1 plus 4, so that I can say negative 1 plus 1, which is 0. Let's talk about multiplying integers. So similarly, when we multiply two positives, we get a positive. When we multiply negative and a negative, we get a positive. Positive and a negative is a negative. And finally, negative and a positive is a negative as well. Okay, so these are three important rules for integers, right? Those are probably the most important rules. Okay, so let's look at these examples, right? So they only contain multiplication. So firstly, I have negative 8 times 5. So negative times a positive, because 5 is a positive. So overall, my answer for that is going to be negative. And I can just do the calculation. So 5 times 8 is 40. So this is negative 40. Then I'm multiplying still by negative 2. Now I have a negative 40, okay? Negative 40 times negative 2. So this is a negative times a negative. So overall, my answer now is going to be positive. You don't have to write the plus, but yeah. Overall, my answer is going to be positive 80 because it's a negative times a negative. Let's revise this concept. It is multiplication as well. So 3 times negative 2. So that's a positive times a negative. So the answer is going to be negative. And then 3 times 2 is 6 times 4. This is a negative times a positive. Overall answer is going to be negative 24. Let's do some division. Division follows the same concept as multiplication. Okay, so here we have, okay, this is basically 10 divided by 5, positive number divided by a positive number. So our overall answer is going to be positive 2. Let's look at these, right? Again, it's BODMAS. So we only have division. We're just going to do all the divisions in a row, right? So I'm going to tackle the first two. I have a negative divided by a negative. Okay, so my overall answer is going to be positive. 24 divided by 2 is 12. Divided by negative 6. Okay, is equal to, so 12, I have positive 12, negative, the overall answer is going to be negative 12 divided by 6, 2. Okay, I think maybe this is more like the examples you're probably used to. Let's do number 1 and number 4, and then we can move on. So negative, okay, so let's have a look at it. I have negative 3 times 4 times negative 2. So only multiplication on top. So let's address it, right? So it's multiplication, so we can just do it in the order that it comes in. So I'm going to say negative 3 times 4. Negative times a positive is a negative. Okay, 3 times 4 is 12. And I still have to multiply that by negative 2. At the bottom, I have negative 5, negative 3, plus 9. Okay, so negative 5 and negative 3 is negative 8. Negative 8 plus 9 is like saying negative 8 plus 8 plus 1. Okay, the reason I'm splitting it is so that negative 8 plus 8 gives me 0. Let's simplify the top. Negative times a negative is actually going to give me a positive. 12 times 2 is actually 24. Negative 8 and positive 8 give us 0. 0 plus 1 is 1. My final answer is 24. All right, on top, I will follow BODMAS, so I'm going to do brackets first. Yes, technically not a bracket. So on top, 6 times 3, positive times a positive. So my answer is going to be positive 18. You don't have to put the plus, so I'm going to ignore it. 18. Now, negative 10 times 3, the answer is going to be negative overall, negative 30. Plus minus 4. Positive and a negative make a negative overall, so it's going to be minus 4. Here we got to do BODMAS, so we got to do the multiplication first. It's simply 10 times 3, positive 10 times positive 3, which is positive 30 minus 14. And now we can just simplify. So 18 minus 30. That's like saying 18 minus 18 minus 12, I believe. Thirty minus 14 is 6. 18 minus 18 cancels. Negative 12 and negative 4 is negative 16. Divide both of them by 2, you're getting negative 8 over 3. Confirm that that's right. $16, not 6. Correct. Thank you for that. So the final answer here is negative 1. Okay, so those are a revision of basic integers. Let's look at integers with roots, okay, and how they work. So firstly, we have root 1, okay, square root 1, which is just 1. Then we have the cube root of 64. The cube root of 64, we can utilize our calculators for that. The cube root of 64 gives us 4, okay? Basically, it's like 4 times 4 times 4. And then in this case, 1 minus 4 is like 1 minus 1 minus 3 is equal to minus 3. Okay, let's look at the second one. Now, you may have learned that if you have a negative inside of a surd, okay, it's going to be non-real. However, this is not a square root, that's a cube root. Okay, so it works with odd and even powers. So even powers, so meaning like x squared, x4, x6, right? If the power is an even number, these are always positive. They'll always give you a positive answer. However, odd powers, okay, like x, and yeah, I guess x to the 1, x to the 3, x to the 5, and so on. These can be negative. Meaning the answer when you cube something can possibly be negative. So in this case, you can actually take the cube root of negative 8. So the cube root of negative 8 is actually going to be 2, negative 2. So negative 2 cubed, okay? Negative 2 cubed looks something like this. It's negative 2 times negative 2 times negative 2. So this is multiplication. Let's do the first one. Negative 2 times negative 2. Negative times a negative is a positive. And then 2 times 2 is 4. Then you're going to multiply it by a negative again, and you're going to get negative because it's positive times negative, and this time you're going to get 8. So whenever you have a negative to a cube or any odd power, you're going to get a negative. When you have a negative to the power of any odd power, okay, your answer is going to be negative. So therefore, this actually simplifies, and even if you put in your calculator, it will give you a value, it won't give you an error. Negative 2 times, now this square, you take it into there, it becomes negative 5 squared. If you put into your calculator with brackets, negative 5 squared, you're going to get an answer of 25. You're going to get a positive answer. Okay, remember we said that even powers are always positive. Now, please note that there's a big difference between negative 5 squared and negative 5 squared. If you put the top one in your calculator, if you put the top one in your calculator, it's going to give you positive 25. If you put the bottom one in your calculator, you're going to get negative 25, and that is not correct. You should always use brackets. This here is basically like saying negative 1 times 5 squared. The square is only for the 5 and not the negative. Whereas in this case, I'm squaring the entire negative. And remember, this is basically like -5 times -5. Negative times a negative gives us a positive. Okay, so I hope it's making sense. So that's why that either way is 25. Okay, -5 squared is 25. Then I have -2 times 25. A negative times a positive gives me a negative. 2 times 25, 50. Let's look at the last and final one, then we can move on to exponents. Okay, so 81 is the perfect square of 9. So square root 81 is going to be equal to 9. Square root of 9 is actually 3. 3 times 3. 24 divided by 2. So 24 divided by -2. So it's a positive divided by a negative. So my final answer is negative. 24 divided by 2 is actually 12. If we simplify, this is 12 over -12. This is -1. Okay, done. Just I stop sharing my screen for a second. Let me get the exponents. Glad we're starting already. That's really good. And let's begin with exponents. Okay, can you guys see my screen again? I'm resharing. Okay, perfect. Give me 1 second and we'll start. Okay. So, yes, rules of exponents, right? For those, someone said they're starting negative exponents. Let's have a look at it. Okay. So the rules of exponents, we're going to go through them step by step. I believe this is the second time you guys are learning rule of exponents. I think you guys have learned it last year. So let's go through them and let's understand them, because in order to answer the questions, you have to have a great understanding of how the rules work. You go and implement it in your practice. If you're still confused, you come back to the rules, remind yourself of the rules, and then go back to practicing. Okay? Because all the rules are, all the questions are just the rules. You're just utilizing the rules. So if you understand the rules properly, you'll be able to answer all the questions that they throw at you. So again, rules of exponents, right? So here we have this rule number 1, where I can see that I have the same bases. So A is my base, and the bases are multiplied and they have different exponents. It doesn't matter. But the fact is I have a base times a base, which is the same base. So the same base times the same base, which in this case it's A times A, and then different exponents, whatever. It doesn't really matter about the exponents. All I care about is that the bases are the same, they're in multiplication. That's when I add the exponents. I can write it under one base and add the exponents. So similarly, you have to know how to work backwards as well. What I mean by backwards, if you are given something like b to the power of b to the power of x plus y, okay, you need to note that this can go backwards. You can take each of these powers to the base and multiply them, right? It's backwards of rule 1. So this is equal to b to the x times b to the y. It's equally important to go with this, if not more important. Okay, so basically, same basis in multiplication, you can add the exponents. Okay, let's move on. The next one, same basis in division, you can subtract the exponents. Same basis, but now they are in division with one another. You therefore subtract the exponent. Whatever the exponents are, you can say top minus bottom. Okay, yeah, generally you can say top minus bottom. That works. And then of course you have to work backwards as well. If you are given something like b to the x minus y, okay, actually, firstly, what I want you guys to note is b to the x minus y. Let's write this a bit bigger. b to the x minus y, okay, b to the power of x minus y can be simplified as this, but it can also be simplified as multiplication. I just have to say b times b to the power of x times b to the power of negative y, okay? Because this is basically like an addition. It's like saying x plus negative y. So if it was plus, right? If it was plus, remember I can do this. I can split it in the same basis and multiply. Okay, alternatively, it could also be written as b to the x over b to the y. Okay, just like the rule. But this middle one is equally as important to know. Okay, let us move on. Number 3, we call this the power to the power. Okay, it's basically when you have a base. Right, you have a base and you have an exponent. So like a to the power of x. Sorry, you have a base to the power of x. Okay, and then you have that in itself to another power. So in that case, what do? You take the two powers and you multiply them to create one power. So this is going to be equal to a to the power of x times b. Okay, that's crucially important. A to the power of x times b. This is known as a power to a power. Okay, then we have a to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So x to the power of 0, 1. 17 to the power of 0, 1. That big amount is 1. Okay, anything to the power of 0 is in fact 1. Let's talk about a negative exponent. So negative exponents, okay, basically, if they are in the numerator, you can take them to the denominator to make them positive. And if they are in the denominator, you can take them up to the numerator to make them positive. So if you want your answer to be in terms of positive exponents, you can always take these to the numerator or denominator. So in this case, right, what we actually have is a to the power of negative x over 1. So I took it to the bottom, because anything can be written of 1. I took this guy to the bottom, and it became 1 over a to the x. Okay, so if I do an example, if I have b to the negative 3 times a to the 2 divided by c to the 4 times by d to the negative 2. So just say I wanted this answer with all positive exponents or positive exponents. If I wanted it with all positive exponents, whatever is negative, I'm going to take it to the top or take it to the bottom. So basically, in this case, what is negative? What's negative is b to the negative 3 and d to the negative 2. Okay, if you have a question, please ask it in the chat. Okay, so b to the negative 3 and d to the negative 2, those are the negative ones. So all I can do is I can take it to the denominator to make it positive, and I can take this to the numerator to make it positive. I just have to take it to whichever one it's not in. Okay, so let's do that. If I wanted it as all positive exponents, I could still have my a squared, but then I'm going to multiply it by d squared as well. So do you see what I did? Instead of having d to the negative 2 at the bottom, I put it to the top and I could change it to positive. Then at the bottom, I still have c4, and I'm going to multiply it by b to the positive 3 because now I took it to the bottom. So the negative ones, you can take it to the top or take it to the bottom. Like terms. What do you mean like terms? Okay, so that's if I wanted all positive exponents. Alternatively, if I wanted no denominator, basically, If I wanted no denominator, okay, I could take everything to the top. So this would be a squared times b to the minus 3 times c to the minus 4 times d squared. I hope that makes sense. Everything on top would look like that. If I want no denominator, then I can take everything to the top in such a manner. That making sense? Let's look at the last two. So firstly, let's look at this one. Okay. So I have a times b to the power of x. So essentially, I have a multiplication or a product, okay, holds the whole thing to the power of x. Simple. I just distribute that x. Sorry, forgive my computer. So I just distribute that x as a power to each of the terms inside of the brackets, as can be seen here. Note, if we're working backwards, let's just say, okay, let's do another example. Either way, x to the power of, no, 7a squared. I distribute the square to the 7 and the 8. So this gives me 49a squared. Okay, what if I had to do it backwards? Okay, if you're doing it backwards, just say you have x to the power of 10a. Let's just do 10b. X to the power of 10b. This can be written as, I can split it. Remember, it's 10 times b. It's like having, wait, no. Oh, this was for the other one. It's fine. Okay, but backwards would simply just be then, if you have 10 to the power of q times 4 to the power of q. This could be equal to, since they both to the power of 2, you could group them as 10 times 4 to the power of q, which can then simplify to 40 to the power of q. Okay, basically, how that makes sense. Okay, let's just do one more backwards for this one. If you have b to the power of 10c, this could be split as b to the power of 10 to the power of c, or it could even be split as b to the power of c to the power of 10. It doesn't matter because they both become, when you multiply them, they become 10c either way. Okay, so that's important to remember as well. Let's look at the last one. If I have a fraction, the whole fraction to a power, I can simply distribute that power to each term in the numerator and denominator respectively. So the backwards way of this is easy. If you have, let's just say 49 over 25. So this could be written as 7 squared over 5 squared. Now, since they have the same exact power, okay, since they have the same exact power, they could actually be written as 7 over 5 squared. Okay, so just keep that in mind. Let's move on to simplifying surds. Now, simplifying surds is easy. Okay, what do we have to do? We have to write the value inside of a surd. So what does it mean to write it as a product with a perfect square? So basically, remember, as a multiple. Okay, so basically, we just want to write multiples of 50, and one of the multiples, factors. One of the factors needs to be a perfect square. So can somebody give me a perfect square that is a factor of 50? A perfect square that is a factor of 50. 2 is not a perfect square. What is a surd? Okay, a surd is represented by this symbol here. I think maybe you guys use the term like square root or something. Or just a root in general. What term do you guys use? A surd is basically this. It's represented by that root. Okay, 100, you're giving me a multiple. You're giving me a multiple of 50. That's a perfect square. I wanted a factor. So indeed, it would be 25. Okay, so a factor is a number that goes exactly into another number with no remainder, and that would be 25. So basically, 50 can be written as 25, okay, times 2. Let's just rewrite it. 25 times 2. Now you'll see we'll actually do the first surd rule, that when we have a multiplication inside of a surd, it can be separated into its own surd. Does that make sense? When we have a multiplication inside of a surd, so basically here's my surd, and I have a times b. I can rewrite this as square root a times square root b. In this case, I can write this as square root 25 times square root 2. Now, why did we specifically choose to write it as a product with a perfect square? That's simple, so that we can actually take the square root of 25. Square root of 25 is 5 times square root 2. And that's how you simplify the surd. That's how you simplify the surd to 5 root, we call it 5 root 2. Okay, let's do another example. Let's say square root 32. Can somebody give me a perfect square that goes into 32? A perfect square that is a factor of 32. Very good, very good. 16, right? 16 is a perfect square that goes into 32. So we can separate, so we can write 32 in its factors as 16 and 2. So you can skip this step if you'd like. Okay, so let's skip it in this time. In the next example, we won't. So basically, like I'm writing it as a product of a perfect square so that I can at least take the perfect square out. I don't have to keep the entire 32 in. I can take a part of it out. Okay, because remember, like 16 times 2 is 32. I didn't change the value of anything. This is still equal, most definitely. Okay, so if I want to take this out, the 16, to take something out of a square root, you have to square root it. That only makes sense. So when I take 16 out, it becomes 4 root 2. Okay, let's do another example. And this time we're not going to skip that step. Let us do square root 98. What is a perfect square that goes into 98? How did I do that? By square rooting 16. How did I get from 16 to 4? I'm taking it out of the surd or the square root. So I need to square root it. Okay, 49 definitely does work. So 49 times 2. Okay, so now I'm not going to skip the step and I'm going to show the long way. So remember this rule, right? We're going to go through all the surd rules next time. But this first rule is key for now. When I have square root x, y, I can simplify this as square root x times square root y. Okay, so in this case, I'm going to say square root 49 times square root 2. Square root 49 simplifies to 7, and I'm left with root 2. Let's just say we have a bit of a weird number. Let's just say 64, for example, right? Let's just say What can we say? Let's do 80. Okay, let's just say you don't find the highest. We've done 80 already, I think. Oh, no, we didn't. Let's just say you don't find the highest value. Just say you chose 4, which is a perfect square. Okay, so you chose to express this as 4 times 20. Then you got square root 4 times square root 20. Then you got 2 root 20. But you'll notice that 20, there's another perfect square that can go into 20. Okay, and it's 4. So what you can do is you can do it again. So you will say 2, just in case you must it right the first time. 20 can be written as 4 times 5. And my perfect square is 4. So I can then write this as 2 square root times square root 4 times square root 5. Now remember, square root 4 is 2, so it becomes 2 times 2 times square root 5, which then simplifies to 4 square root 5. Okay, I saw a question now and then it disappeared. Okay, so if you perchance don't take the highest possible perfect square that goes into the number, and you take, like, for example, 4, it just means you have to probably do 2 or more steps. How you got to the last 2 steps? So how I got to the last 2 steps, I'm separating square root 4 and square root 5 because it's a multiplication within a surd. So I said 2 times square root 4 times square root 5. I split this square root 4 times 5 into square root 4 times square root 5. Then square root 4 is equal to 2. I simplified this. I simplified square root 4. That's why I chose the perfect square. Square root 2, and then I already had the 2 there. Sorry, square root 4 gave me 2, and then I already had the 2 there. So basically, all I had to say was 2 times 2, and then square root 5 is unsimplifiable, and I'm left with 4 square root 5. Okay, so I'm happy with that, right? Next time, what we'll do is we will continue with rules of surds. Okay, so we'll do number 2, number 3, and then we'll do a few of these examples. Okay, when are you guys writing your test? When are you guys writing your maths test? Okay, some this week, some next week. So basically some this week, some next week. Okay, so for those of you who are writing this week, take some time to go through the rest of the surd rules, okay, which are basically square roots, and then go ahead and attempt some of these questions. So when we rejoin next week, okay, we will continue with fractional exponents and surds, and then complete all the examples. Then after this topic, we have numeric and geometric patterns, actually, which we will do thereafter. Factorization. Factorization. We didn't do any factorization yet, but we did highest common factor and lowest common multiple. Factorization will probably be at the start of next term. But okay, cool. Let's end it there. Thank you guys so much for joining. I will see you guys next week, Sunday then, same time. All the best. Okay. Thank you. Jazakallah. Assalamu alaikum.